Energy expenditure. Energy out refers to the amount of energy the body uses to sustain its basic physiological functions, which are breathing, digestion, maintaining body temperature, muscle activity, etc., and to perform normal daily physical activities. The amount of energy the body needs to perform these activities is influenced by a number of factors, including gender, age, weight, height, and level of fitness. Energy burned per kilogram of weight in a 30-minute time period. So in your textbook on page 494, you will find this table. This table shows the amount of energy burned per kilogram of weight in a 30-minute time period. So using the formula E equals R times W times T, where E equals the energy burned, R equals the rate of energy used in kilojoules per kilo per 30 minute, so that would be the rate that you get from the table, times the weight or your weight in kilograms, and times how many 30-minute intervals you have done that exercise for. So let's have a look at an example. Use the table to estimate the energy that is burned by a 67 kilo girl dancing for 30 minutes. So using our formula, E equals R times W times T. If we have a look at our table, we can see that dancing is 9.1 kilojoules per kilo per 30 minutes. So we're going to have 9.1 times the weight. The girl is 67 kilos, so 9.1 times 67, and she did it for one 30-minute interval, so it's times 1. And that will equal 609.7 kilojoules. So this girl dancing for 30 minutes will burn 609.7 kilojoules. Let's have a look at another example. Use the table to estimate the energy that is burned by a 73 kilo man jogging for 50 minutes. So once again, we're using the formula E equals R times W times T. And if we have a look at the table, we can see that jogging is 17.8 kilojoules per kilo per 30 minutes. So we're going to have E equals 17.8 times the man's weight of 73 and then times the interval. Now he has been jogging for 50 minutes. So we're going to put 50 over 30 as a fraction. And if you type all that into your calculator, the energy burned will be 2,165.7 kilojoules. Basal metabolic rate, or otherwise known as BMR. Another way of calculating the amount of energy used in an activity involves using the concepts of basal metabolic rate, or BMR. BMR is the minimum amount of energy needed to sustain bodily functions for a 24-hour period, measured in kilojoules per day. An estimate can be calculated using either the Schofield formula or the Harris-Benedict formula. Let's have a look at the Schofield formula first. The table below shows the Schofield formula and how to calculate the estimated BMR for females and males of a particular age using their weight. This table is found on page 496 of your textbook, and as you can see, there is a column for females and a column for males. So you need to look down the age column for the age of the person that you're calculating it for, and then whether they are female or male, you do whichever one is in which column. So let's have a look at an example. Use the Schofield formula to calculate the basal metabolic rate of a 17-year-old girl who weighs 55 kilos. So if we have a look at the table and we go down to where 17 falls in the age brackets, which is between 11 and 18, we go across, we can see that she's a female. So we're going to use 56 times W plus 2,898. So her BMR will equal 56 times, her weight is 55, so times 55, plus 2,898, which equals 5,978 kilojoules per day. The Harris-Benedict formula is also used for estimating BMR in kilojoules per day. There are two different formulas for females and males. We can see here that the female one is 2,783 plus 40 times the weight in kilograms plus 7.7 times height in centimetres minus 19.6 times age in years. And for males, it is 278 plus 57.5 times weight in kilos plus 20.9 times height in centimetres, minus 28.2 times age in years. Let's have a look at an example using the Harris-Benedict formula. Use the Harris-Benedict formula to calculate the basal metabolic rate for a 21-year-old boy who weighs 82 kilos and is 181 centimetres tall. So if we have a look at our formula, it is 278 plus 57.5 times weight in kilos plus 20.9 times height in centimetres minus 28.2 times age in years. If we put in the information we know, we have BMR equals 278 plus 57.5 times 82, because he weighs 82 kilos, plus 20.9 times 181, because he's 181 centimetres tall, minus 28.2 times 21, because he's 21 years old. Now make sure when you're putting this into your calculator that you're using your brackets, okay? That will avoid any calculator errors. And if you type that all into your calculator, you will get a BMR of 8,183.7 kilojoules per day. Physical activity, otherwise known as POW. The physical activity level is the total energy needed for an activity compared to the BMR. So the physical activity level, or POW, is the result of the comparison between total energy needed for the activity and the BMR. For example, a physical activity factor of 1.7, okay, so a POW of 1.7 indicates that the activity requires 1.7 times more energy than the BMR. The energy output needed is then given by energy out equals basal metabolic rate times physical activity level, or energy out equals BMR times POW. Let's have a look at some examples. Here is the table for the physical activity level, or POW. It's on page 497 of your textbook. And if we have a look, there are 6 different stages. So stage 1, or lifestyle stages. Lifestyle stage 1 is little to no exercise, so more or less doing nothing. These are people who are in hospital, people who have a limited ability to move, okay? Now their POW, or physical activity level, is 1.2. That's the factor. Lifestyle level 2 is little physical activity at work or leisure. So they're an office worker, sitting at a desk all day, not doing much physical activity, and their POW is 1.45. Lifestyle 3 is seat at work with some occasional walking and standing, no strenuous leisure activity. They're like laboratory assistants, drivers, students, assembly line workers, and their POW is 1.65. Lifestyle level 4 is predominantly standing or walking. Okay, so they're people like homemakers, salespersons, waiters, mechanics, okay, and their POW factor is 1.85. Lifestyle level 5 is heavy occupational work or highly active leisure. So they're construction workers, fitness trainers, those people that are really active in their job, and their POW factor is 2.2. Level 6 is significant amounts of exercise in addition to 2, 3 or 4. So you just add extra POW units. So let's have a look at an example. A 32-year-old woman weighs 60 kilos and is an office worker. Use the Schofield formula to estimate the woman's BMR. Okay, so we need to do that first. All right, so using the Schofield formula, the BMR will equal 34 times 60 because she weighs 60 plus 3,538 times, which equals 5,578 kilojoules. Part B, use the power table to estimate the energy this woman needs to maintain her lifestyle. So what do we know about her? We know she's an office worker. So we can see that she would be in level 2, lifestyle level 2, which has a PAL of 1.45. So the energy out will equal BMR times PAL. We know that her BMR equals 5,578. Multiply that by 1.45 and we get her energy out equals 8,088.1 kilojoules. So that's the estimated energy she will need to maintain her lifestyle. Also in your textbook on page 499 are a few different activities and what their POW level is. So if we have a look, energy out equals duration of activity in hours times BMR in kilojoules per hour times POW. Okay, so in the table we can see that walking at 4 kilometres per hour has a POW of 2.9, down to volleyball, which has a POW of 6.5. And this is per hour. So if we have a look at an example, a 28-year-old woman who weighs 62 kilos and is 163 centimetres tall plays soccer for 1.5 hours. Use the Harris-Benedict formula to calculate the woman's BMR. So putting in the formula that we learned earlier, the Harris-Benedict formula, you can go back and look that up if you need to. We can see that the BMR will equal 2,783 plus 40 times 62 because she weighs 62 kilos, plus 7.7 times 163 because she's 163 centimetres tall, minus 19.6 times 28 because she's 28 years old, equals 5,969.3 kilojoules per day. Now energy out will equal 1.5 because if we have a look at how long she's playing it for, she's playing it for an hour and a half. Now the formula for energy out when using this, we need to do how many hours, so that's 1.5 hours, times, we need to do her BMR per hour, so we need to divide it by 24. So it'll be 5,969.3 divided by 24, and then times by 10, because soccer in our table has a POW of 10. And that will equal 3,730.8 kilojoules. And we'll just do one final example, estimating the time needed to burn kilojoules. So if a 52-year-old man weighs 90 kilos, part A is use the Schofield formula to estimate the man's BMR. So if you need to, flick back into your book to find the Schofield formula, and it will be BMR equals 48 times 90 because he weighs 90 kilos, plus 3,653, which equals 7,973 kilojoules. So that's the man's BMR. Part B is how long would it take the man to burn 1,500 kilojoules of energy by running at 9 kilometres per hour. So before we were calculating how much energy an activity will create, this time we know how much we want to create, so we want to know how long we're going to have to do the activity for. So on that table, running at 9 kilometres per hour has a POW of 8.6. So it's our time that we don't know this time. So we're letting T equal the activity or duration in hours that we need to perform this activity to burn 1,500 kilojoules. So our formula will be 1,500 equals T times 7,973 over 24, because once again that number needs to be the BMR per hour, times 8.6 because that is the power for running at 9 kilometres. Okay, and if you do 7,973 divided by 24 times 8.6, you will get 2,856.991667. So our equation is 1,500 equals T times 2,856.991667. So we will divide both sides by 2,856.991667, and we will get that the time will equal 0.525 hours. And if you just push your time key on your calculator, that will convert to 32 minutes to the nearest minute.